Hello, this is Paul from Foresight Tech. In this lecture, I will going to introduce probability distribution. And the last section we deal with the basic probability, right, of the events. This way, if we learn the probability distribution, we will be easy, okay, to deal with the probabilities. First, let's look at the probability distribution for discrete random variable. So the first one we're going to learn what is a random variable. Okay, that's the foundation of distribution. So if we look at a random variable, the definition is here. It's using x. So like a variable, right? But it is not a normal variable. Then we learn basic mathematics like algebra. If we have a variable x, give you an equation, like the equation is x plus 1 equals 0. We can definitely find the solution for x. I mean that x is not a random variable. Okay, so what is a random variable? Random variable is still a variable but associated with the probabilities. Okay, in algebra our x does not associate with the probability. We give two examples. So we have two types of random variable. So the first, discrete random variable. What it means discrete? 1, 2, 3, this discrete number, right? For example, if we flip a coin 3 times, flip the first time, flip the second time, flip it the third time, to record the number of heads you get. So what's the possible value? So if this is a random variable for the number of random for the heads, how many heads you possibility to get? So can we see? So probably you get a 0, means the first you get a tail, right? Or among the 3 times you get a 1 head, or probably you get a 2 heads, or probably you get a 3. This is the maximum possibility. Can you see, right? What's this number? The value is discrete number. So for this variable, okay, so we call the discrete random variable. Why is it randomly? Once you do the experiment for 3 times, you flip the coin 3 times, you are not sure before you do the game. You are not sure what kind of results you will get. So you probably get a 1, probably get a 0, probably get a 2 or 3. Each one has a kind of probability, and we're going to deal with the probability distribution later. Okay, and the second is continuous. We give an example. So if you're going to ride the bus, okay, if your child is going to ride the bus to school, before you're going to ride the bus, can we see the waiting time? So probably 0, probably 1 minute, probably 30 minutes, but also probably be any time between 0 and 30. For example, if it's between 0 and 30 minutes, is this possible? Yes. Okay, so any numbers, what is number? This number is a continuous number. From 0 to 30 is an interval, right? We learned. This we call the, so this waiting time we call the random variable, continuous random variable. And this one we deal with discrete. Okay, so the next section we're going to deal with the continuous random variable. Okay, let's look at it. If we deal with the discrete, what's the probability? Remember these questions? What's the probability to get 0, or probably get a 1, or get a 2, or get 3 for this random variable? Okay, and this probability we put it together. Okay, we put together, build a table. This table we call the probability distribution. What does it mean? So x is the random variable. X could be pick 0 or 1 or 2 or 3. Each probability is between 0 and 1, right? Because this is a probability, a chance. And the second, if we put all the probability together, what do we get? That's 100%. Okay, so that equals 1. So any probability like this kind of function. Okay, so this time we call the probability distribution function. This is a function. Usually we call the PDF, probability distribution function. Okay, so this we call it the distribution. You can imagine, see, if we have 0, 1, 2, 3, each number we have a kind of probability. If we draw a bar graph, or we draw like a histogram, and you will find what? If you draw a bar graph, you find it looks like a histogram. Yes, definitely. That kind of a histogram is a probability distribution. So you will say the histogram is you can select the same with the relative frequency table. Do you remember? We learned the frequency table, right? And the frequency table we also can draw bar graph or we can draw histogram. And the look is very similar. Yes, definitely. They just like each other. Please be sure we have one major difference. And the probability this random variable usually is not just based on data, okay? Is a kind of theoretical study. It's for what? We studied the population. Do you remember the basic? Okay, our statistic is get a sample from population. Behind the sample is population. So random variable study on population. Keep in mind that. And what is the frequency table? Relative frequency table or distribution. That's based on sample. You learn how to draw histogram. Or the histogram based on data, right? So there are two. These two are totally different. Okay, even they look is very similar. Random variable is a study for the foundation, population, and the relative frequency table or basic histogram is based on data. Okay, is from sample. Now, I will show you a few examples how to get a probability distribution. Okay, if we have a probability distribution, so do you know the purpose? You're going to deal with the events. Okay, this is a little bit the difference. Okay, from algebra. Keep in mind that any axis is related to probability. Okay, we'll look at the first questions. Okay, I put here. Can you see? Now we have this question. If we flip a coin once, okay, flip a coin once, and count the number of heads, okay, if the coin is fair, okay, we based on the coin is fair, you either get a head up or get a tail up. So what do we do? Got to write the probability distribution for the number of heads. So first, probability distribution is for random variable, which is the random variable, of course the number of heads, right? And then how to find the value first. This variable could pick what kind of value, and then you find the probability. After we get this, we build a table. So can you see step by step? Okay, so the first we need to do this. Okay, determine which one is the random variable. Of course, is the number of heads. We use x. Okay, we use x to describe this random variable. The second step, this is a random variable, means the value is randomly picked, assigned. What kind of value? So can you see? Flip once, how many? Possible value is only 2, right? So either get a 0 or get a 1. Means what? If you get a 0, you get a 0 heads, means flip, you get a head, you get a tail up, right? So this means get a tail, this means get a head, see? And we one by one. So look at it, the probability. Now it's easy to find the probability. If you get no head, head is 0. If it means x equals 0, do you know this is the notation? Okay, the basic. Usually we call it, if you ignore this 0, is called the px, the PDF, right? Okay, this means the probability to get this value is just the probability to get a tail up. So what the probability to get a tail is 1/2. Okay, this is a classical model, right? Classical model. So this is a basic classical model. You flip one coin, get a tail up. Get a tail up is 1 success outcome over 2 our total outcome. So it's 0.5, right? So the second, if you want to get one head up, means what? Flip a coin, you get a head up. What's the chance? The chance is still 1/2. Okay, now you finish it almost. See, these axes could be these two numbers. Each number associated with the kind of chance. You have 50 chance to get a 0. You have 50 chance to get a 1. Yeah, definitely. Now you have everything. If we put everything together, is this. Can we look at? Okay, did the last step. We build the table. Okay, build the table is only. Do you remember? So the basic table, right? So the first row we call the x, means the value of x. What the value? The value is either 0 or 1. The second row we put the chance or the probability. What the probability for 0 is 0.5, we found it. What the probability for 1 is also 0.5. Okay, and we add these two together. Can you see? 0.5 plus 0.5 equals 1. Do you remember the definition for distribution? Probability distribution is all the probability is between 0 and 1. This is definitely between 0 and 1, right? And the second is the sum added together, summation equals 1. That definitely. Okay, so this is basic follow the definition. This is the first example. It's the easiest example, right? Yes. And then not always the random variable has only two value to take. So we look at this example. We have more than 2. Now we have more than 2. Can we look at the, so they are the same. Okay, flip the coin, but this time is flip twice. Can you see? It's not once. Flip 2 times. They count the number of heads and then build a probability distribution. Okay, build the table. It's just the first row is the value, second row is the probability. Okay, now so they are step by step. Everyone know the first step. Random variable is x, right? Determine the number of heads among 2 flips. Okay, what's the value this time? You can imagine, of course. You have 3 this time. Why is it 3? And if you flip twice, probably you failed each time, right? Means you get a tail, no head. And it is 1 head or 2 head. Can you get 3 heads? Impossible, right? Because you only flip twice. And the maximum number for the heads is 2. Okay, now another step, the step 3 is count the probability. What is the probability for 0? We move one by one. Okay, then now we're going to see. I did not write the answer here, so let's going to write down what's the probability. X equals 0 means no head. No head means tail the first time and tail the second time, right? So this means what? This is the first flip get a tail, right? This means what? The second flip you also get a tail. But these 2 times, you remember, these 2 steps of probability. We learned the multiplication probability. So how do you do? This should be do the basic calculation, right? Okay, that's going to do should be this. Okay, the first probability times the second probability, right? And it is independent to each other. So what is the first probability? Flip coin get tail is 1/2. I wrote a 0.5. Okay. The second is the same, right? It's DR 0.5. Okay, this is times. And then the result is 0.25. Right, we get a 0.25. Okay. And then we move to the second. You want to get the 1 head. Okay, imagine, you think about the probability. You get a 1 head means what? You have 2 choice. See, you could the first time get a head or the second time get a head. Okay, these 2 added together means the probability this time is the first get a head, right? And or the second time you get a head. You see, so this probability calculate this. Okay, that's going to calculate. The first probability, everyone know, is 0.5 times 0.5, similar with the first one. So it's 0.5 times 0.5, right? This is the first. What the second? So they are the same. Okay, 0.5 times 0.5. You do calculation, how many we get? We get 0.5, 50% of the chance you get a number 1. Okay, and then is number 2. Number 2 get 2 heads. What is 2 heads? 2 heads means get a head and a head. Okay, so we do the multiplication. So the first is 0.5, right? The second is still 0.5, and what the answer is 0.25. Now you know you finish this and this together, right? And then plug into the table. This is the probability distribution table. What is 0 probability? And this random variable could pick a 0 or 1 or 2. What is the probability for 0? Is 0.25. So I put here 0.25. And I put 0.5 for 1, put 0.25 for 2. Okay, so now is this a probability distribution? Yes, because all these probabilities between 0 and 1. The second, can you going to look at the sum? Yeah, definitely equals 1, right? No problem. At this is 0.5, at the 0.5 is 1. So that's good. So we just deal with these two examples. Do you remember at the beginning? We said that this distribution looks like a histogram. Now I will go back to draw the histogram. Do you know how to draw the histogram? Okay, this is the first example, right? We just flip once, and now the random variable follow this distribution. We definitely visualize this distribution in a kind of histogram. Let's see. Okay, I draw here. If I put this is x, okay, this is the number. Put this is the height for probability. If this is the probability, and then the value is 0, 1. I don't put a 0 here. Okay, it's okay. I'll just put a 0 here. It's okay. And then I put a 1 here. Now what is the bar? How tall is each one? Is 0.5, right? If I say this is 0.5. Okay, now we see how high this is. This high. How high is this? Also this high. And then remember the histogram we draw, we don't have a gap, right? So it's better to draw this. See? And if I draw this is the first bar, and then we have the second bar. Okay, I draw this. Did the second bar. If I highlighted it the first, highlighted this the second. Can you see? Is this histogram? Yeah, definitely. So this means what? And the variable x has a 50%. This is very similar like the relative frequency. Do you remember the histogram? 0.5 is 50% to get 0, 50% to get 1. 50% get 0, 50% get 1. Okay, and the second, we will draw the similar. It's very similar. Okay, but you can say this just look like a histogram. No problem. Okay, so usually we call the distribution, and you think it's a histogram. No problem. And we look at this, a little bit of difference. Okay, we're going to draw. Okay, like as this time I need to draw a little bit wide, like the y as they are described as a probability. Okay, and then the x is for the value. So we have a 0 to pick, or 1 to pick, or 2 to pick. And the first 0.25, I say this high is 0.25. If this high, the chance is 0.5, means 50%, 25%. And can you see? No gap, right? Remember, if I draw the box, okay, it's like this. This is the first, and then the second is going to 0.5. Can you see? It should be this high. And the third is only this high. Okay, and then if I highlighted the first, and the 25% to get a 0. Did the second, 50% to get a 1. Did the third, and 25% to get 2. Still look as histogram. You can just imagine, okay, the look is very similar. How to visualize the distribution. And also from this we know. So what the mean? Okay, the mean is in the middle because this is symmetric, right? So we learned that before. Okay, the last question. The last question. Can you see this? If this is a distribution, okay, a probability distribution, sometimes we just call it distribution, okay, a discrete probability distribution. We say we have a distribution, and this is the possible value, and this is the probability for the value, and now we have a missing value of the probability. What is this? Okay, now the questions over this. How to find this? Do you remember the definition? So first, this number should be between 0 and 1. However, that's not useful for you to determine. The second is joined to this. Do you remember? All the possibility or the chance put together, I mean you add the sum together equals how many? 1, number 1, 100%. Okay, for example, 10% get this, 20%, 30%, 10%, what is the chance to get this number 5? Okay, everyone knows, right? So we're going to find that this value should be the probability x equals 5. Okay, so here we do this, put the probability. Okay, and this value is mean the probability I just pick 5. How to pick 5 is 1 minus all the sum of others, right? Is 1 minus, because all added together is 1. So this number is 1 minus all the other numbers. So 0.1, 0.2, 0.3, 0.1. And then you do calculations, 1 minus 0.7. Okay, so how many? Is 0.3. 30% of the chance, right? See, we can determine the missing value. Okay, so the first part, the basic random variable and the distribution. Thank you.